Okay, guys, we are on lesson 74. So this is going to talk about two types of formulas that we can use for sequences. And they are the recursive and the explicit. So in lesson 73, we already saw the explicit formula. So now we're going to look at what the recursive formula looks like and the difference between the two and why you would use one over the other. Okay, so first thing is in the do now, we have if n equals 10, find n plus 1 and find n minus 1. Okay, so this is an expression that we're going to see a lot of, and we just want to understand really what it means in terms of n. So if n is 10, then n plus 1 is just 10 plus 1, so that means it's 11. So n plus 1 is the number after n. And then n minus 1, in this case, would be 10 minus 1, which is 9. So n minus 1 would be the number before 10, or before n, right? So same thing here. If n is 5, n plus 1 is 6. And n minus 1 is 4. So n plus 1 is the number after n, and n minus 1 is the number before n. And then if n is negative 2, n plus 1 is negative 2 plus 1, so that's negative 1. And then n minus 1 is negative 2 minus 1, which is negative 3. And again, n plus 1 is the number after, think of the number line for negative numbers, and n minus 1 is the number before it. Okay, so this is what I want you to really get out of this do now, that n plus 1 represents the term or number after n, and then n minus 1 is the number or the term before n, right? So when you see that in the formulas later, that's what I want you to think of. All right, so what are these two definitions or formulas? So explicit definition. An explicit definition gives the equation based on the general term a sub n. For some reason, when I printed the PDF, a lot of my math type came out a little bit small. So hopefully that doesn't give you a problem, but if you print it out, hopefully you can at least see it. If it's on the screen, you might have to kind of zoom in on some of these. So based on the general term a sub n, it enables us to directly compute any term. So if you needed to find the 100th term, you could use the explicit formula and jump right to the 100th term without having to find the whole sequence beforehand. All right, then you have the recursive definition. The recursive definition is an equation for a sequence that is dependent on the output of the previous stage of the sequence. And a recursive definition has two parts. So that means you need the previous term to get to the next term. So this is not an equation that I would want to use if I needed to find the 100th term of something, because that means I need the 99th. And to get the 99th means I need the 98th. And to get the 98th, I need the 97th, etc. So this would take a long time. Okay, but sometimes it's easier to just write it as a recursive first. So that's why we have these two ways. So it says for arithmetic, we talked about this in lesson 73. Okay, so a sub n equals a sub 1 plus d times n minus 1, where remember, a sub n is the term in that spot, right? So that's the actual term. A sub 1 is the first term. And D is the common difference, right? So that's basically if you went backwards, what the difference was. If you went forward, it's what you're adding to get to the next term. And then N is the term spot. So that's like the parking spot number, right? So that's like the 100th term or the 50th term. And then this is what's in that spot. So that's like your final answer. This is given to you on the reference sheet. Okay, so we talked about the explicit for geometric as well, right? So a sub n equals a sub 1 times r to the n minus 1. So a sub n means the same thing. It's the term that's in the spot. N is the spot number you're in. A sub 1 is the first term, and then r is the common ratio. So if you go backwards and divide, this is what you get. Or you can think of it as this is what you multiply by to get to the next term. Okay, so now we have recursive formulas. So again, they're different depending on which type of sequence it is. So for arithmetic, you always start with given the first term. So they have to tell you a sub 1 equals whatever number. And k is just some number. We don't know. Whatever number it is. Same thing with geometric. They give you the first term. Then they give you a formula using that first term. So the formula is a sub n, which is just meaning the next term, equals a sub n minus 1 plus d. So let's break this down. So this, a sub n minus 1, this is one thing. This is a notation that means the term before. So if you want a sub n, let's say that's the 50th term, right? You want the 50th term, you need the 49th term first, and then you just add d to it, and that will give you your a sub n, right? So this is just an expression. So I wouldn't get so hung up on plugging in n here, plugging in n here. That's not really what I want you to do. I want you to see a sub n minus 1, and I want you to think term before this term, okay? And then you just add d. Same thing here with geometric. You're going to take a sub n minus 1, which is the term before this term, and you're going to multiply it by r. I don't know why that multiplication symbol is like up higher. Like I said, when I printed this PDF, for some reason, some of the math type came out a little bit off. So that should be like a multiplication symbol down here. For some reason, it's up there. So for geometric, you're going to take that term before this term and multiply by r. So if you want to find the 12th term, that means you need to know the 11th term, which is a sub n minus 1, term before it, and then just multiply by r, okay? Now, sometimes the first term is given as a sub 1, sometimes it's given as a sub 0. When we write our own explicit, rather recursive formulas, I always use a sub 1 because then that will make sense for these formulas. If it's given to you as a sub 0, then it's just kind of off by 1. We might see that later on. I forget if there's an example like that. Okay, so let's look at an example where we have to actually write our own formulas. So it says write both a recursive and an explicit definition for each sequence. Then find the indicated term of each sequence. So we're going to write the recursive formula, then we're going to write the explicit formula, and then we're going to find the 50th term. Okay, so first I have to decide, is it arithmetic or geometric, right? So I'm looking at this pattern here. So I have 4, 8, 12, 16, 20. So it looks like it's adding 4, right? And then again, I can always go backwards and check. So 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. 20 minus 16 is 4. So I know that it's arithmetic and D is 4. So let's do recursive first. So it looks really complicated because it's like 2 parts and then there's this like subscript thing now that's new to us. But it's actually the easier one to write because you just literally say what you're doing. You're saying, okay, here's your first term, which they gave me is 1. So I always tell them, here's the first term. And then I just tell them what to do to get to the next term, which is to add 4 to the previous term. So I'm going to say a sub n, which just means to get whatever term you want this to be, you're going to take the previous term. And the way we say previous term is a sub n minus 1. And we're just going to tell them add d. And d is 4, so just add 4. And that's it. That's my formula. It's 2 parts. Okay, so recursive always has to be 2 parts. That's it. And if I now wanted to find the 50th term, though, I would have to plug in and find the second term, and then use that to find the third term, and use that to find the fourth term. And I would have to keep going down the line. And that's not really efficient, right? So that's why we also have the explicit formula, because the explicit formula can help us jump to whatever term we need to get to. Okay, so this one, we need to follow our formula up here. So this one, we're going to say a sub n equals a sub 1, so the first term, 4, plus d, which we said was also 4, times n minus 1. So n is staying in the formula because then we can plug in n to be whatever we need it to be later, okay, which we're going to do here in a second. However, I usually want to simplify this if I can. So if I can distribute and then I can combine like terms, 4 and then minus 4. So it ends up actually being 4 times n. Okay, so sometimes people think that they could just like write the explicit formula because they know, oh, it's just adding 4, so I'll just put n plus 4. Well, what you're really trying to do is this one, and it's not n plus 4, it's a sub n minus 1 plus 4, right? So don't try to like take a shortcut here and say, oh, I know how to do it. I don't need to use this formula. I'll just write plus 4, okay? Because it's 4 times n. Remember, n is the parking spot number. So look at what these, spot number 1 is 4, spot number 2 is 8, spot number 3 is 12, spot number 4 is 16. Think about what you're doing. You're taking the spot and you're multiplying it by 4. That's what this formula is. So now if I want the 50th term, I just need to do a sub 50, which just means the 50th term is 4 times the spot, which is spot number 50, and that gives me 200. So the 50th term is 200. And I found that without having to find all the other 49 or 48 terms, right? Okay, so same thing here. Let's try this one. So 2, -1, -4, -7, right? So I'm seeing that it's going down. So I know that if it's arithmetic, it's going to be negative. If it's geometric, it's going to be a fraction. So let's see which one we think. So we see it's going down by 3. This is going down by 3. This is going down by 3. So it seems that it's a arithmetic and d is -3. Okay, and again, I can go backwards and subtract, and I see that I get -3 every time I go backwards and subtract. So first is recursive. So that's the 2 parts, right? So I always start with the first term. So the first term is 2. So I tell them, hey, first term is 2. Then I use the a sub n and the a sub n minus 1. I tell them what to do with the previous term. What do you do with 2 to get to the next term? What do you do with -1 to get to the -4? So we're going to say, to get to the next term, which is a sub n, you're going to take the previous term, which is a sub n minus 1, and you're going to minus 3. So you can either write plus -3 or just minus 3. And that's it. So think. 2, take, if you want the, so this is the first term, right? So if you want the second term, the second spot, that means you're going to take the first spot number, which is 2, and minus 3, and you get -1. If I want the third spot, I'm going to take the second spot number, which is -1, and minus 3, and that gets me -4. So that's what this notation is just meaning. Okay, so that's your recursive. Then you have explicit. So explicit is the one we did in lesson 73. So this one is a sub n equals a sub 1, which is the first term, so 2, times, oh, I'm looking at the wrong one, sorry. This is arithmetic. So 2, hold on, get my white out. Okay, so I got my first term still, and it's plus, since it's arithmetic, so plus d, which is -3, times n minus 1. And again, I want to clean this up whenever possible. So I'm going to distribute that -3, 2, and then plus -3n, or just minus 3n, and then -3 times -1, so positive 3. So then I can add my like terms. So a sub n equals -3n, and then plus 5. Sorry. Okay, so now I'm going to take my 50 and I'm going to plug it in. So a sub 50 equals -3 times 50 plus 5. Okay, so I have -3 times 50, so -150 plus 5, so -145 is my 50th term. Okay, so when they ask me for that 50th term or whatever term, I'm going to use the explicit to get that. Because if I use recursive, I'd be sitting here forever writing down the entire sequence. Okay? All right, so let's go ahead and see if we can try some geometrics. All right, so here we have 2, -6, 18, -54. So first I'm looking at it, I'm deciding if it's arithmetic or geometric. It looks like the difference is changing, so that's not going to be arithmetic. Does it look like I'm multiplying by something to get to the next term? It looks as though I am. The signs are changing. Again, I can go backwards and divide and see what I get. So -6 divided by 2 is -3. 18 divided by -6 is -3. -54 divided by 18 is -3. Okay, so R is -3. So I'm going to use my geometric recursive formula. So recursive for geometric still has 2 parts. You still need the first term, which is 2, and you still are going to tell them to get the nth term. You're going to take the previous term, which is a sub n minus 1, and you're going to multiply by what we said R was. So you're going to multiply by -3. Okay, and you could write it like that. You could say that it's a sub n equals -3 times a sub n minus 1, right? So that might be more pleasing to look at that way. But it doesn't matter. You're multiplying by the previous term. And then for explicit, that's what we saw in lesson 73. So a sub n equals the first term is 2 times R, which is -3 to the n minus 1. Okay, and notice how only the R is raised to the n minus 1. Okay, so this is your base, and then this is the coefficient of that. So when we want the 20th term, that's what we're going to plug in to n. And think about why it's got to be n minus 1, because you already have the first term, right? So you already have the first term is 2. So you have to multiply by -3 19 more times, not 20 times, because you already have the first term. So a sub 20 equals a sub 20 equals 2 times -3 to the 20 minus 1, which gives us a very large number, or small, I guess, if you're thinking about it as a negative. So -2,324,522,934. Okay, so obviously we get such a big number because we have a geometric sequence, which we said the other day is really an exponential function, right? So the other ones were arithmetic, so that means that they are linear functions. They're growing by a constant. Here we're basically multiplying by -3, right? You're tripling it. The signs are going to fluctuate back and forth, but it's obviously going to grow. The actual number part is going to grow much faster, or decay, depending on what R is. So speaking of, in the next one, you have 21, 7, 7/3, 7/9. So you see right away it's going down. So if it's arithmetic, it would be negative. If it's geometric, it's going to be a fraction. So we see that it looks like it's decreasing by different amounts. So it's not going to be arithmetic. So 21, 7, 7/3. So it looks like it's dividing by 3, right? But remember, it's what you're multiplying by. So although I might look at it and think divide by 3, I have to know that that means multiply by 1/3. So R is 1/3. And again, go backwards and divide. 7 divided by 21, 1/3. 7/3 divided by 7, 1/3. 7/9 divided by 7/3, 1/3. Right? So if you're unsure about what R is just by looking at it, go backwards and divide. Okay, so recursive. A sub 1 is 21, and a sub n, what am I doing with the previous term to get to the next term? That's what old recursive is showing you. I'm saying take the previous term and multiply by R. So multiply by a third. You could write divide by 3, right? Because we know that multiplying by a third is the same as dividing by 3. So this could be written other ways, but it comes from the fact that you're multiplying by r, which is a third. So again, 2 parts for recursive. Explicit, which I forgot to circle over here. Okay, so explicit for this one, a sub n equals a sub 1, which is 21, times 1/3 to the n minus 1. Okay. And then this time I only want the 10th term. Okay, so a sub 10 equals 21 times 1/3 to the 10 minus 1. Oops, can you see that? Okay. All right, so you can plug that into the calculator. If you make it into a fraction, or if you use the fancy fraction, it will give you the fraction as output. So 7/6,561 was the answer. If you got a decimal before you change it to a fraction, it's something like this, 0.00100, nope, 0.0010066 something. But anytime you can write it exactly as a fraction, then that's what you need to do. Otherwise, you're basically rounding. Okay. All right. So now we have these 2 examples where they give you a recursive formula and then they want the explicit. Or here they give you the explicit and they want the recursive. Okay. So you're basically transforming the formulas, right? So example 2 says the recursive formula for a geometric sequence, and again, I don't know why these came out so tiny, is a sub n equals 2 times a sub n minus 1 with a sub 1 equaling 5. Find an explicit formula. Okay, so the first thing I want to do is write down my explicit formula for a geometric, so I know what I need. So that is on the front of your lesson. It is also a formula that would be given to you on the regents on the reference sheet. The recursive formulas are not, just the explicit. Okay, so the explicit geometric is a sub n equals a sub 1 times r to the n minus 1. So I need the first term and I need r. So I see the first term they gave me, a sub n equals 5. R is what I multiply by to get to the next term. And if you just look here, it's 2 times the previous term. Remember, a sub n minus 1 is the previous term. So that's R. So the R is 2 to the n minus 1. That's it. That's my explicit formula. So by transforming the recursive to the explicit, that now allows me to find the 100th term if I needed to. If I had this only, I'd be sitting here forever trying to find 100 terms. But if I can transform this into an explicit, then all I got to do is plug in 100 and I'm good to go. All right, if you weren't sure what the R was, if you looked at this and said, I think it might be 2, but I'm not sure, you could just generate the sequence and see the numbers, right? So the first term is 5. The second term, you take the 5 and you times it by 2, and that's 10. Then the third term, you take the previous term, 10, and times it by 2. That's 20. Then you take the previous term, 20, and times it by 2. That's 40. Right? So you can just generate the sequence and then say, oh yeah, it's multiplying by 2, so that's the R. Okay? Then it gives us the explicit for a geometric, and it wants a recursive. Okay? So recursive, we know, is a sub 1 equals whatever the number is for the first term, k we'll call it. Then a sub n equals a sub n minus 1 times whatever r is, right? So I need to look at this formula and I need to find those 2 pieces of information. I need the first term and I need what r is. Now here's the thing you have to be careful of. This looks like it's the explicit formula that we have, right? But it's not. It's to the nth power. And our formula is to the n minus 1. And that is going to make a difference here, because if I want the first term, I'm going to plug in 1. And if I plug in 1 here, this is not the first term. If this was n minus 1, then when I plug in 1, this would be my first term. This would be a sub 1. But when I plug in 1 here, 5 to the first is 5. So it's 5 times that number. That's the first term. So we have to be careful about how they present the formulas to us. Okay, so I'm going to kind of do the same thing as I did up here. I'm going to generate the sequence. And the way to generate the sequence is just plug in the spot numbers. N is 1, spot number 1, what do you get? N is 2, spot number 2, what do you get? So that's what we're going to do. So if a sub 1, that's the first term, I'm making n 1. 5 to the 1 is 5 times 2 is 10. So the first number of my sequence is 10. So that's what I need to put here. Okay, so I'm going to write a sub 1 equals 10. Then I'm going to find the second number. So 2 times 5 to the second power. So 5 to the second is 25. 25 times 2 is 50. I'm going to find the third term. 2 times 5 to the third. So 5 to the third is 125. And then 125 times 2 is 250. Right? So I can see, okay, this is still R. It's still multiplying by 5. 10 times 5 is 50. Times 5 is 250. So this is R. I just couldn't assume that this was a sub 1 because the exponent was n rather than n minus 1. So I just generated a couple terms. Now I can confirm, yes, the R is 5. So my recursive formula is going to be take the previous term, which is a sub n minus 1, and times by 5. Or you can write it like with the 5 in the front if you like that better, like that, right? So now if I use this, I would get the same sequence. So the recursive formula and the explicit formula, or this particular formula and this particular formula, generate the same sequence. Okay, oh, sorry, I didn't realize I was off camera there. Okay, so you can write it like this, times by 5, or you could put the 5 in the front. Doesn't matter. They both mean the same thing. Okay. Okay. So last two examples that I want to go over. So this is a question that we see a lot with kind of sequences displayed as exponential functions or linear functions that are kind of real world scenarios. So the population of Jamesburg for the years 2010 to 2013 respectively was reported as follows: 250,000, 250,937, 251,878, and 252,822. How can this sequence be recursively modeled? So again, reading is really important here. So we are looking for a recursive model or equation or formula, right? That's the first thing that I would kind of check off. So recursive formulas have two parts. They have the a sub 1 and then the formula telling you what to do with the previous term. So choices 3 and 4 are recursive models. They have the first part and the second part, the first part and the second part. These are explicit formulas. So those are out right away just because of the fact that they said it had to be recursive. So now we're down to 50-50 shot. So basically, you can sit here and try to make the formula from these numbers, or just use these two choices now instead of all 4. Use these two choices to generate the sequence and see which one gives you this pattern, right? So it looks like, if I just look quickly, this is saying take 250,000 as the first term, which is true, and this one has the same first term, so that's both right. And then this looks like it's just adding 937, which is what this is saying. Take the previous term, this just means previous term, and add 937. Well, that looks good, that works. But is that gonna keep working? If I add another 937 to this, am I gonna get this as my answer? And if I do that, add 937, I'm not getting this. So if I add 937 again, I'm not getting that. It's not working as an addition. So this is out. So I'm going to think that this is my answer, but I'm going to double check it. And I'm going to take 250,000 and multiply it. This means take the previous term, multiply it by this number. And I should get something obviously close to this. It's going to probably be rounded to that. And then take that answer and multiply it by this number again. And I should get that answer. And then take that answer and multiply it by this number again. And I should get that answer. And that is going to be the correct answer. Okay, so use those choices to help you decide if it's even modeled correctly. If it didn't say the word recursively modeled, then choice 1 would be the explicit model that would give you this pattern as well. Okay, so you have to make sure you're reading. Okay, last example I want to do is generate that sequence, which we kind of talked about already, and this really comes down to the notations. Like if you don't understand the notations, then it gets super confusing. So if you understand what the notations are representing, then it's just kind of being cautious and careful and, plugging them into the right spot and calculating. All right, so generate the next 4 terms. So they already gave you the first term because this is a recursive formula. So they're already giving you a sub 1 equals -1. So I'm going to write that down. All right, so things to remember. A sub n means like the next spot, right? So the next term that you're finding. Then a sub n minus 1, that means the previous term. So the previous answer, or if we're going back to my car analogy, the previous car in the spot. And then n is the spot number, right? The parking spot number. So if we had, oh God, I was going to draw a car. I'm just going to draw a circle. So let's just say that's a car. And this is parking spot number 1. This is another car. And that's parking spot number 2, right? So this is the n. And then the car that's in that spot is the a sub n. Okay? All right. So if I want the term that's in the second spot, right? So that's what a sub 2 means. What's the term in the second spot? I'm going to follow this formula. I'm going to say it's 2 times the previous term. Well, the previous term was this guy, -1. So I'm going to multiply by the previous number, which is -1. And then it tells me, I'm just following whatever the formula tells me to do. Then it tells me to add n. Add n is the spot number I'm in now. I'm in spot number 2. So I'm adding a 2. So now I'm going to calculate this and see what I get. So 2 times -1 is -2. -2 plus 2 is going to be 0. So in the second spot is a 0. All right, now I want the third. What's in the third spot? So a sub 3. So I'm going to go back to the formula. 2 times a sub n minus 1. All that means is what was the previous term. So what did I get for the previous answer? 0. So that goes here. Then I'm following the formula. It says to add n. Add, well, now I'm in spot number 3. So I'm adding 3. So 2 times 0 is 0. 0 plus 3 is 3. So in the third spot, there's a 3. Then I'm going to do the fourth spot. Who's in the fourth spot? So I'm going to go back to the formula. 2 times a sub n minus 1 means who is in the previous spot. What's the previous term? It was 3, right? So I'm going to put 3 here. And I'm going to add the spot number I'm in. So I'm going to add, well, now I'm in spot number 4. Equals 2 times 3 is 6 plus 4 is 10. And they want the next 4 terms, so I need one more. So what's in the fifth spot? So 2 times the previous is 10 plus, what spot am I in? I'm in spot number 5. So, oops, we don't need that. So 2 times 10 is 20 plus 5 is 25. So that means in this sequence, spot number 1 is -1. Spot number 2 is 0. Spot number 3 is 3. Spot number 4 is 10. Spot number 5 is 25. And that is my pattern. Now, it's not recursive or, sorry, take that back. It's not arithmetic or geometric. It's just a pattern, right? So that's the other thing about the recursive formula, is that we can use that to write other sequences that are not necessarily geometric or arithmetic. Not every sequence is going to fit into one of those two categories. And then the other thing with this is that sometimes you just make a mistake. So it's always good to kind of go back and just double check that, okay, the n should be matching this 3, 3, 4, 4, 5, 5, and that your previous answer is what you're plugging in for the a sub n minus 1. Okay, and this is the other thing, is that if you mess up here, obviously everything after that's going to be messed up too. So you really have to be conscious when you're filling in these sequences. Okay. All right, so see if you can try the practice and the homework questions, and check with the answer key after you've given it a good effort. Okay? Stay well, guys.